In this section, we're going to go over some JavaScripting fundamentals that will help you in creating scripts for your TIA visualization projects. Before we start doing examples, I want to go over some resources that are at your disposal that will greatly help when you are writing scripts for your projects. The first one is the JavaScript reference page at developer.mozilla.org. The links will be in the course resources, but this is a fantastic resource on the language itself, and I am going to be referring back to this quite a bit, how to use it, how to get information out of it. The other two resources are documents put out by Siemens. One is the Semantic WinCC Unified Tips and Tricks for Scripting in Java, and it has quite a bit of information on the different functions and how to use scripting, when to use scripting, and I refer to this resource quite a bit. And section 5 has some specific tips for Unified. It goes over such things as snippets, goes into descriptions of all the different functions that are available, also file handling, math, all kinds of stuff. There's also a section on diagnostics, how to use the trace viewer, and things like that. The last reference is the JavaScript style guide, and this gives you some really good information on the rules that have been applied to JavaScripting in Unified to make sure that we don't run into errors. Also programming styles, for instance, using curly braces and using block codes and how to declare variables and things like that. So this is another really good resource, and I highly recommend going through and taking a look at this. If you follow these style guides, then you're going to be less prone to having bugs in your code. It's going to be a lot easier for someone to come behind you and modify the scripts if they have to, because the scripts will be easier to read and they'll conform to standards. So highly recommend these three references. So we're going to start with doing some examples manipulating strings. And if you have not done the debug window project that we did in the last video, where we have a global debug window that we can print to, I highly recommend you go back and do that first, because we're going to be using that for this and future sections. So we're going to start on the JavaScripting page. And I did have a debug window down here as well that we created during the interim steps of doing the debug project. I've deleted that to give us a little bit more real estate. So let's just start with a button. And on the properties of this button, for my text, I'm just going to put string examples. And I'll open up my scripting. And if we look at our global definition, you can see that I've gotten rid of our debug.write and our debug.read functions because they referenced the screen that we had here. So to go back and review how we use our debug, which is our global module, we have a debug and a write function. And the write function takes a source, so that might be the name of a button or the name of a script, and a message. So we need to be sure that we send it a source and a message. And our clear function basically doesn't take any arguments, it just clears the screen. So going back to JavaScripting, first we're going to start with printing out our constant value of pi. So I'll hit the script function to get to the script area on our button. And we're going to be doing different styles of commenting here. JavaScript uses C-style commenting. So 2 forward slashes, and I'll just put 1 printing value of constant. And to use our debug, we just do debug.write. And the first argument is going to be our source. Now, if you remember, item, which is passed in, is a reference to the object we're calling from. So we can just do item.name. And then we'll do a comma, and then our message will simply be the value of pi is, and then I just reference pi. Now JavaScript is case sensitive, so if you get your case wrong on your variable or your constant names, it's going to throw an error. We can also do local variables. It's highly recommended to declare all your variables at the top of the script. You don't have to, but it makes it for easier reading, and it can also help keep away bugs. Sometimes you try to use a variable before it's actually been declared. So let's just say let value1 equal, and we can just give it a number. We'll do a string variable, let greeting equal, and we'll just do hello world. And then we will just print these out using the plus to append. And we'll just do print local variable values in a string. Debug.Write. And we'll also do item.name here and do greeting plus, and we'll do a semicolon, another plus, and then value equals value 1. And then we will just do a compile check. Looks like everything's okay. We'll go back to properties and let's test this out in runtime. So I'll just save the project and go to runtime. And we'll go to JavaScripting. We'll need to open up our debug window, so our printouts are going to go here, and we'll just click the button. So we can see both of these came from button 5, and it's print out the value of pi from our global constant, and then there's our greeting, and then there's the value from our variable. So now let's look at some examples using values from a tag and maybe doing some addition. So we'll go back to the engineering environment, and I'm going to go to our read tag button. And if you recall from an earlier exercise, we've already done this where we read the value of a tag using the tag object and just printing it out. So I'm just going to grab this and I'll use Control-C to copy it, and I'll go to my string examples. And here I'll use my block quote from C where you do a / asterisk and then an asterisk / to close it out, just to show you kind of different ways of commenting. And I'll just do print tag value and I'll paste my code. Now it's good practice to do your variables at the very top of your script, so I'm going to follow that convention. I'm also going to add another variable, and I'll do value2, and I'll say it's equal to 50. But this is different than our value 1 because you can see that that is a number and this is a string. It's a string because we included the quotes. So let's do a couple of examples of doing addition of whatever the tag speed value is to both an integer and to a string and see what happens. I'm just going to copy this code here, and I will do speed tag plus value 1, and I'll just put a note that it's an integer is, and we'll do tag speed value plus value 1, and then I'll do another plus to do a period. I always do that because sometimes you have an empty string and you think for some reason it didn't print out, so I like to put something at the end. And then let's also copy this, and we'll just change our comment. This is a string, and I'll change this. So what do you expect is going to happen? Well, let's see if what you think happens actually does. So I'll save that, and we'll just go to runtime. So we'll open our debug window, and I'll put something, let's say there's a 45 in the tag. So I'll just hit the button. So you might have thought that the first line would be the addition of 45 and 76, which is 121. But instead we got 45 and 76, so it basically just treated them both as strings. Then the second one, it did exactly the same thing. It just did the string 4550. It didn't actually do mathematical addition. Why is that? Well, if we go back to our code, it's because we set the precedent when we started this whole thing off as a string, and so it just assumed that everything was going to be a string. So how can we fix this? Well, in the case of an integer plus an integer, we can't just put parentheses around it and say, hey, this is kind of special, and within the scope of these parentheses, they're both integers, and it should add them. But I wonder what happens if we do the same thing to the string. Will it just automatically convert value 2 into the numerical equivalent, or what? Well, let's take a look. I'll save this and go to runtime. So I'll put up our debug window, and hit the button. So now our integers are adding because we've put them into kind of their same order of precedence using the parentheses. But since value 2 is a string, it's going to have to just convert the whole thing to a string. So how do we fix that? If we want to do mathematical addition, we have to convert the value of value 2 into an integer. So I wonder how we do that. So let's go to Mozilla, to our JavaScript reference, and we're on the title page here. And if you look at the function properties, we have something called parse int, parse float, among some other functions. The parse int function, you can give it a string representation of an integer, and if it is an integer, it'll use that value. If it's not an integer, it will return not a number. So now, armed with this knowledge, we'll go back to our engineering environment, go to our script. So we're going to convert this value using parse int, and make sure you have the exact same case as the function, or it'll throw an error. The compiler will not catch it. And so what we have is value 2 is converted to an integer, and this is also an integer, so it should work exactly like this one. So let's save and go to runtime. So we'll open our debug window and hit our button, and you can see that it does work. So for our last example for strings, I want to tackle the example we did in the last section where we put a script on the change event of our screen window object to update the text in the text box. So every time we navigate, it gives us the name of the screen that we navigated to. But as we noted then, it also puts the server prefix on there. So we want to get rid of the server prefix. So in this case, it would just say plant objects instead of HMIRT1 : plant objects. So how do we do that? We need to look for a string function in the JavaScript reference that will allow us to either replace the server prefix with nothing, which would just leave performance inside, or if we could find the point where the last colon is in the string, we could just print the remainder of it and it would give us the same results. So if we go to our JavaScript reference on the main page, if you take a look here, under text processing we have string. So it gives us a description and said that there are functions that allow us to check the length, concatenation operators, checking to see if a string exists within another string using index of, or extracting substrings with a substring method. That last one sounds promising, so let's go take a look at that. So in this example, they give us the string Mozilla, and here they're printing out the substring that starts at 1, which is the O, and it ends at 3, which is non-inclusive, so we only get OZ. In the second example, they give you a substring, but they don't specify an end index. So when they start with 2, M being 0, O being 1, Z being 2, it prints the rest of the string out. So that looks like it's going to work for us. And so we just need to do the name of whatever string we have and then add substring and find the index at the end of our server prefix. So going back to our engineering software, we're going to go to our main page where the script is located on the screen window object. And under properties, screen, we'll go to the change event. So item.screen is a string, and we can just do substring. And if we look at our HMI runtime _1, that's 3, 4, 5, 6, 7, 8 characters plus 2 colons, that's 10. So we're going to actually start at 9, and that's because the very first character starts at 0. So let's see how this works out for us. I'll do save project and go to runtime. So we start out with welcome, which is the default, and if we navigate, it looks like we are still showing our colon. So that means we needed to go one more index, which makes sense if you think about it. So we'll go back to our script, and instead of a 9, we're going to need a 10 here to go one more to start at the first character of the name of the page. We'll save this and go to runtime. So back in runtime, we'll navigate, and we've taken care of the server prefix. So now I have an assignment for you. So for the first step in the assignment, if you didn't code along with the video, please go back and follow along with the video and write the code as I do on the strings example button. Just pause the video when you need to catch up and test your code. Next, I want you to update the script on the screen change event on your main display window screen object on your main page to remove the server prefix from the displayed screen name in your text box using the substring function with a hard-coded index. For example, I hard-coded 10 to eliminate the server prefix. Once you've got that to work, comment out the substring function and instead use the JavaScript string index of function to find the index of the colon character in the screen name and just calculate the index required to show only the screen name without the server prefix. This will be a more generic solution because you may not know how long the server prefix is. So we're going to go to the JavaScript language reference for that. Once you have that one working, we're going to solve it a third way using the JavaScript string replace function to just replace the server prefix with an empty string. Finally, I have a challenge. In the project, when we open the debug window, it always opens in the top left. What I would like you to do is find a solution so that when we pop it up, it always appears by default in the bottom right. So go ahead and pause this video, complete the assignments, and then come back to this video and I will show you how I did it. I'm going to start with the third assignment using the index of function to find the index of the colon character in the screen name and calculate the index required to show only the screen name. Let's take a look at the JavaScript reference. The index of comes from the string page, or this is how I got to it under the description. It talks about index of, or you could just search for index of. And the syntax allows you to call it with a search value and optionally with a start index. And in the example, they give you a paragraph to search and they define a search term, which is dog. And they call index of with the search term. So index of first ends up being a 40. And if you count these characters, that's 40 characters right there where I've highlighted. So it finds the first occurrence. So let's see if we can use this to calculate where we need to cut the string off to get rid of the server prefix. So we'll go back to our software and I'm going to just start by doing a button on the JavaScript page just so I can kind of play around with it. And once I get it working, I can just port the code over to our screen window object. So for the properties, I'll just do index of example and I'll go to events, click left mouse and open the JavaScript. So let's just create a variable. Let screen name equal, and we'll just make up a screen name, but we're going to use our server prefix of HMIRT1. So HMIRT1 : and then my screen name. Doesn't really matter what we put here. We're just looking for the end of the colons. And then let's find out our index. Let first index equal, and we'll do screen name dot index of, and our string is simply colon. We could actually do both colons. It actually doesn't matter. And if we print this out, it's going to put us at the index just before the colons. We could just increment this by 2, and that should bypass both of our colons. So if we print this out and it ends up being 10, then we know we're right. So we'll just use our debug.write function. This is our item.name, which is our button, and just say first index of screen name is, and we'll just do plus first index plus period. So let's go to runtime and see what we've got. So we'll pull up our debug window. And it does give us a 10, which is exactly what we used. So we can just simply go back to our software. So I'll just copy this, go back to main, and go to our change script, and I'll just put this in here. And item.screen has our search string in it, so I'm just going to copy that and replace screen name with this. And then since first index will get the correct index, we can just copy that and put it directly in here. So let's check it out in runtime. So we'll navigate, and it in fact does work correctly. So the next assignment was to just try to use the replace function to also solve the same problem. We'll go back to the string object page, and here on the side, these are all the methods that we have for the string prototype. So here is our replace function, so we'll just go there. And it shows you that they're replacing dog with monkey. You can use a regular expression. We're going to use a substring. So the substring that they use is replace dog with monkey. And what we're going to do is just search for the server prefix and just replace it with nothing. So we can just use replace. So let's go back to our software and we'll go test it out on the JavaScript page. So I am just going to copy this button and paste it just so our code stays there. And then on properties, I'll do the replace example. And we go to our script, we're going to use the same screen name. And here we will just call this new screen name, and it's going to equal screen name dot replace. And the first argument is what we're going to replace, which is just going to be our server prefix. And we want to replace it with the empty string. And we need to update our debug message. So this should be the old one with the server prefix intact. And this should be the new one that has the server prefix replaced with nothing. So we can save this and go to runtime and test it out. So we'll go to JavaScripting, pull up our debug window, and hit our replace example. So here is our screen name with the server prefix, and here it is without the prefix. So that looks like it works. So we just need to go back to our code, and we can just copy this part, go to our main screen, and go to our properties, and here's our script. And I'm just going to copy this whole thing here, paste it down here, and we can just comment these two lines out from the last example. And then we can paste in our replace statement, and we need a semicolon. So this should just replace the server prefix with an empty string and basically do the same thing that the last two examples did. So we'll just check this out in runtime. So we'll go to our JavaScripting page, and you can see it's already working. So this is just an example of there's several ways to solve a problem. Sometimes they're equal, sometimes some solutions are more efficient than others, but I just wanted to give you a sense that you can accomplish the same thing by different means. So the next example was to change the code on the debug window button on our main screen to make our pop-up appear in the lower right-hand corner of the screen versus the top left. So let's go back to our engineering software and take a look at our main screen. And this is a system function. You may guess that left and top is the coordinates of the top left-hand corner of the window when it appears. And of course, 0, 0 is going to be top left corner of the main screen. Now we could do some math and figure out how big main screen is and how big debug window is and calculate kind of where they should be and play with it. But since this is a scripting class, let me show you a neat example. Let's go to our debug window, and I am going to just add a button here. And on the text of this button, I'm just going to put get coords for coordinates. And if we look at the events, I'll go to the JavaScript. If we think about it, there's nothing on this page that I could really get the coordinates that are going to be what we want. What we really want is the coordinates of the picture window that is showing this page. We could say that that picture window is the parent of any control on this page. So if we can get access to the parent, then we could get the left and top position wherever it is. So we could just place it in that position, hit the button, and get the coordinates. So let's just make a variable. Let debug window equal, and then we can just hit our screen dot parent. This should be our debug window. And then we could just use our debug function to print out what we want. So first we will just say parent equals, and then I'm just going to copy this because we're going to use it 3 times. And I can just do name because debug window is already looking at the parent, and then put a semicolon to separate it and say left equals left, top equals top. This should print out the debug screen window that's holding this pop-up, its name, its left coordinate, and its top coordinate. We'll hit save, and we'll check it out in runtime. And I'll just hit get coordinates, and it prints out exactly what we expect, 0, 0, because that's where the script is placing it. So if we move it down and put it exactly where we want, and hit get chords, we get 1307, 558. So we could move it around if we want, but let's just go with 1300, 545. So we'll go back to the TIA software, go to our main page, and on our debug button, we could just do 1300 and 545, save it, and go back to runtime. So we'll pull up our debug window, and it pops up exactly where we thought it would. So in the next module, we'll continue working on JavaScript basics. We'll look at the if function, as well as relational operators and logical operators.